Welcome everybody to the last lab walkthrough of the semester. We're going to be covering mammals. Please bear with me, it's going to be a long one. If you've read the lab activities, there is a lot of material to cover. Normally we would have an entire room full of skeletons and skulls and furs and everything else for you guys to look at, but we don't, so I had to kind of recreate that from scratch. So, moving on. First things you want to be looking at. So we're looking at the monotremes, right? These are the outgroup of mammals. They are the most quote-unquote primitive because they have the most ancestral traits still, such as being oviparous, right? So that's here. You can see that they lay eggs. So remember, oviparous, though, is not an apomorphy for this group. Lots of things lay eggs. Reptiles lay eggs. Birds lay eggs. Lots of dinosaurs lay eggs. Amphibians lay eggs. So, now, eggs are different, but being egg-laying does not make that an apomorphy. That is an ancestral trait. What unites them is that they're lacking teeth as an adult. Now, it's a little more specific. Okay, also, the monotremes are going to be found only in Australia and New Guinea area. One of the first that we're going to look at a little more closely is going to be the short-beaked echidna, also known as the spiny anteaters. What you want to notice on them, they got these short, stubby legs. Modified hairs that are nice, big, spiky things. What you'll notice if you watch the video, you go to the link in the lab activities. There's a really cool thing on the monotremes and how well adapted they are to where they live, and you'll see how their claws are good for digging into the dirt, and how they can kind of bury themselves. So even a dingo that can bring down, something the size of like a cow can't get at these things because they just kind of hunker down. It's kind of a bummer that we don't have you guys in the lab because we actually have an actual preserved specimen of this as well as a preserved platypus, and we're one of 3 schools in the entire country that actually have a real specimen. They're very tightly controlled, and apparently somebody just went out and snagged one about 50 or 60 years ago before anybody cared. Moving on. Another famous monotreme is the duck-billed platypus. This is one of nature's oddest creations, but we love them because A, they're adorable, and B, look at them, right? But one of the things that you want to take note of is that only on males, they have a venomous spike on their hind leg, right? You can kind of see here with the skeleton, right? But it does inject venom. It's not fatal. It might kill a dog, but apparently it is horrendously painful. And you'd want to avoid getting spiked at all costs. Again, on that little platypus, on the monotreme video that you'll see in the activity section, there's one swimming around. And if you're ever having a bad day, look up videos of platypuses swimming, or baby platypus, like you see here. Because how can you be upset looking at something like that? Again, they lay eggs, and that just kind of makes them cool. They are mammals, so they do have this hair, as you can see, and they also secrete milk, but they don't have nipples. Right? That comes along with the marsupials and something else. So if they're going to secrete this milk, it could just come through modified sweat glands, and it just kind of comes out like regular sweat in a located area, specialized area. Moving on, we got the marsupials. Right, things to remember. Now we're looking at things that are viviparous, meaning that they give live birth. Right. They have the marsupium. Marsupials have a marsupium. They have a fetal birth stage. So you'll see more of that in a second, but they're born in a very, very fetal state. And now we're starting to see the presence of nipples, something for one of the, for the babies to latch onto. And it's a very, designated spot that milk to start coming out at. Come in all sorts of shapes and sizes to fill ecological niches. So you got things like a marsupial mouse, we'll look at more than a second, kangaroos, koalas, not bears, and one of my personal favorites, the wombat, right? And so that, even though they seem to fill a very similar niche as to their placental counterparts, if you remember you're looking at this evolutionary tree, their last common ancestor with placentals was tens and tens of millions of years ago. So even though they may fill the ecological niche or may look similar, unrelated whatsoever for dozens and dozens of millions of years. So what we've got here, we talked about how they have a live birth, but they have a fetal birth. Okay, so let's see how do I play that without that. There we go. So you can see it pops out, right? It's born, but it's basically a walking, a little squirming fetus. So this is a kangaroo, right? And it does big, powerful hind legs. Haven't happened yet, and so it's going to take about 3 minutes. I don't think it's not that long. And it's going to be born. It's going to crawl its way through its mother's fur until it can get into that marsupium. And once it gets in there, it's going to latch onto a nipple, and it's going to stay there for 34 weeks in terms of the kangaroos. So that's what, 6 months, almost 7 months, while it grows and finishes its development. That same developmental period would be happening inside the womb for the placental mammals, and we're still born. Humans are. Oh, crap, I forgot about that. That's an adult kangaroo. In case you thought they were always cute.
Stop it.
That can be kind of scary.
You'll bloody break the thing.
Oh, I forgot that was there.
Oh, God, crap.
Sorry.
Yeah, you need to keep those.
And then, just to lighten up the mood, babies. And then we got a little anteater. That's not a marsupial. That's just cute. Moving on. One of my all-time favorite animals is the wombat. They're surprisingly large. They can get up to about 40 pounds, I believe. But one of the funniest things about them is their poop is cubes. They poop out cubes. Right? That's not altered in any way. It just naturally, the way that their digestive tract pushes things out. There's actually academic papers figuring out how they poop cubes, and it's really interesting. But we're not going to get into that. Anyway, the common wombat. Common wombat is just another really interesting and really cool example of a marsupial. Next, we're going to look at a marsupial mouse. Right, there's the proper name for it. But just to keep in mind, this looks almost identical on the surface to a regular placental mouse, like a regular mouse that you've known your entire lives. But this is a marsupial. They got the pouch. They're marsupials. So there is no connection between these and a regular mouse for dozens of millions of years because they're marsupials. That split was so long in the past. But there's an ecological niche of a small mammal that's going to go after seeds and whatnot. And that's it. So evolution filled that niche and gave us the marsupial mouse. Another great example is going to be red kangaroo, right? Everyone loves the kangaroo. Red kangaroos are one of the larger ones. They can be massively large and kind of scary. This particular one, his name's Jeff, right? Just to keep in mind, they can reach speeds of 70 kilometers an hour, but that's only in short bursts. But they can do sustained running of 40 kilometers an hour, about 25 miles an hour, for like 2 straight kilometers. We'll discuss how they move, but their hind legs always move together when they jump, and that's really, really efficient in terms of moving. And this is Jeff. So they are cute and cuddly until they want to break into your house. Probably, yeah.
Shit.
Welcome to Australia.
Stop it.
Not the nicest thing.
You'll bloody break the thing. Oh, God, crap.
Yay! Anyway, kangaroos. You'll notice, you'll see this word rufous. Pretty sure that's Greek or Latin for red. It comes up a lot in the names, like with the red wolf. I think it was rufous. Anyway, moving on. Moving on now to the Xenarthera. It used to be edentata because they thought they had no teeth, but that's not true. So now they're just the Xenarthera. They're this little oddball group of sloths, armadillos, and anteaters. So we got the vermilinguid, which are the anteaters. Don't quote me. I think that's a pangolin. It's a big, shaggy, pretty awesome looking anteater type thing. But they're really awesome and cool. What we've got, so armadillos. Okay, armadillos, they have bony plates in their skin. Now you compare that to a turtle, where its skeleton is its shell, right? Its rib, its shell is basically a modification. It includes its spine and its ribs, and it's grown into there. Armadillos have a proper normal skeleton, which you'd be looking at if we were in lab. But then on top of that, they've got this skin that has bony plates embedded into it. And when we say that they curl into a ball for defense, it's they pop into a ball. They get panicked and they go boop, and they defend themselves. Okay, and so now they are basically encased in a bony, platey ball of defense, and there's not much that's going to get through that. As I mentioned in the lecture, it's not uncommon. You hear some hunter in Texas got shot in the face because he tried shooting one of these, and the shotgun pellets ricocheted off of it and hit the guy in his face or some other body part. So they're pretty resilient. Armadillos, cool. Oh, they do carry leprosy. They have the potential to carry leprosy. That's still a thing, by the way, still in the wild. But they're a carrier. Obviously, they don't have body parts falling off, so don't mess with armadillos. You might get leprosy. Here we've got the three-toed sloth. It is one of my favorite animals of all time. If for no other reason than they're just adorable. But things to make note of. Their claws are so efficient for not moving that they've been known to hang from the trees, exerting absolutely no energy, to the point that they can die and they will still be hanging from the tree because they're just stuck there. I'm showing you, but you can't actually see. So they'll be just hanging there because it takes no effort for them to hang from the trees. And they're one of the only mammals in which you'll see that their fur grows towards the body, right? So it's most other mammals are going to have the fur from the main body, and it grows down towards, like, think of your dog. You pet from the back down to the legs, everything's pointing down. Even you, right? The hair on your arms, everything's pointing down. Sloths have evolved, they hang upside down their entire lives, and so their fur grows towards their body because that's actually pointing down. Sloths have been known to house their own completely unique ecosystems, and their fur in the wild is sometimes be green because it's full of algae and other small microorganisms that grow there. However, in captivity, or at some of the sloth rescues, they need to be groomed to prevent diseases from spreading. And just to end things on a very happy note, let me find how to turn that off. Here we go.
Dry them a while before we blot them with the towel.
When you dry a sloth, you need to drip dry it.
With sloths, there's no need for clothes pegs.
There you go.
And you can see those claws just exerting themselves to
They will
make them
look
just
like
hang.
little puff balls by the time they're done drying.
And that's a baby sloth. That's why I love them. Anyway, the sloth, moving on. One of the few things that could be kept in captivity with no worries because they're pretty chill like that. Okay, briefly, we're going to talk about the general mammal dental plan. We'll cover more of that more specifically when we cover some other animals. But the heterodont dentition, and so what you'll see is that generally speaking, you're going to have incisors, canines, some premolars, and molars going on here, right? There's going to be a million combinations and varieties and variations on this, but the main thing to take away is dental plan, heterodont dentition, things are going to be different. Okay, now we're going to get into the Boreothera. Remember, Thera is just wild beasts, and then it just means it's the boreal and northern distribution. So the different groups, you remember this from the lecture. You got your moles, your Lipophilias, your carnivores, carnivora, primates, apes, monkeys, and us. Right? The Chiroptera can be your bats, and there's actually mega and micro Chiroptera, or yin and yang Chiroptera, depending on which classification system. But you have big bats and you got little bats. We'll cover more of that in a minute. rodents. There's the most species of the mammals are the rodents. They're everywhere. But, like I said in the lecture, lagomorphs, hares, pikas, and rabbits are not rodents. All right, and we'll cover more of that as to where the differences come from in a second. So, moving on, we've got moles, right? Used to be called insectivora, but now they're not. So, moles, they dig underground. They're going to spend most of their life digging. And you'll see when I do a little zoom in here, if you're going to be digging all the time, you got to have really, really powerful muscles, right? So even though, yes, granted they're very tiny, but if you look at their upper humerus here, right, their upper arm section, and you'll see that, boom, right there, okay? Look at all these connections, right? These processes and muscle attachments. They've got some of the most bizarre muscles, and they're supposed to be like that, because remember, everywhere that a bone has a projection sticking out, or it's supposed to, not assuming it's not some cancerous tumor, that's a spot for muscle attachment. And if you're going to spend your entire life digging, I'm making like the swimming motion here, you're digging through the dirt, you're going to need to have a lot of muscle attachment. And you can see that's going on there, all these little processes and whatnot. Now, moving on, we'll look at some classic carnivore. All right, we've got our local California sea lion, Zelampus californius. Okay. We actually have a pelt for you guys to touch if you're bringing it. First of all, there's a reason you make coats out of these things. Just kidding, but they are so soft. But if you look close on their teeth, right? Can you actually see that? Yeah, you can. Right? They do have heterodentition, but they've got a lot of peg-like teeth for fish catching. I would recommend looking up the crab eater seal. Their teeth are really unique looking and very bizarre, but very cool. Moving on from there, okay, also in the carnivore section, we have got the good old American grizzly bear, right? Ursus arcticus, right? That is a brown bear. The Ursus arcticus horribilis, sorry, that is specifically the American subspecies, one of the largest varieties. Depending on which classification system, there used to be like 30 different subspecies, but they've been knocked down to now. You pretty much have inland varieties and coastal varieties, but they are still the same species. Right? They are massive. Right? One of North America's largest predators. But what's really interesting, we're gonna look at their skull. Right? We had a skull for you to look at. So what you'll see, you got this sagittal crest going on here, right? And that is so you can muscle attachment. Right? If you got these big ripping canines, you got these incisors going on here, and they got all kinds of nice little different types of teeth because they are meat eaters, but they eat just as many berries and shrubs and tubers and stuff. They are omnivores, but they're going to be grinding and ripping through all kinds of stuff, and so you need a big place for muscle attachment. So you can see muscle will attach here, right, and then it comes down through that bone there, right, and attaches to powerful jaw. So we're looking at a skull, but we can tell that this thing had a massively powerful jaw, and they do. They're a bear. Right? Now we compare that to just some general carnivore teeth. So what we got here is the skull of a mountain lion, and as you can see, unlike the grizzly bear or us, where we've got grindy molars in the back, they've, mountain lion. This is kind of a standard feline skull, whether it's your house cat or a mountain lion or an actual lion. Look here. No grindy molars going on in the back, right? No grindy molars. They have got just shearing, meat slicing molars. Cats are obligate carnivores. They don't eat other stuff, right? Granted, they'll chew on catnip and some grass for digestive reasons, but don't give a cat a vegan diet, right? Unless it is from your vet, right? And can it be done? Yes, but it's very, very complicated, and most likely you'll kill your animal from not getting the required protein and nutrients that they need. Cats are obligate carnivores. You can tell that by looking at their teeth. They don't have teeth that can grind up plant material. They have teeth that cuts and shreds meat, period. Now, compare that to a coyote skull, okay? Cat skull, all right? There's your mountain lion. And you got that compared to a canine. They do have some grindy molars going on in the back here, right? They're more omnivores. Dogs will eat anything you put in front of them, as you can tell if you've ever had a dog. except for mine. She's weird. But cats, very picky, right? They're famous for being picky. Like, oh, the dogs, they'll eat anything, right? They are scavengers. They're omnivores. They will go after whatever. Yes, a lot of dogs are hunters, wild dogs, and they're very good at it. But they'll eat whatever they can get their hands on, and their jaws are designed for that. And you can also tell that they don't have that massive sagittal crest that you would see. The coyotes have a little bit more of one, but nothing like compared to the bear jaw, or sorry, the bear skull. Right? So there's a little bit spot muscle attachment, but nothing compared to what you saw with that bear skull. And if you take one of the anthro classes, a couple of years ago, humans, right? Well, Arthropistine, we got a sagittal crest and these big, massive, grindy things for chewing raw seeds, which is why cooking is important. It's pre-digestion. Okay, moving on, we've got some of the primates, right? So, well, most primates are carnivores in the sense that they eat omnivores, right? And you'll definitely see that, looking at the tooth patterns of a person, right? But here you got brown-headed spider monkey, and so you got, big long tail. Quick thing, if a monkey has a prehensile tail, that's New World, meaning North and South America. Old World monkeys do not have prehensile tails. They have tails, some of them, but they're not prehensile. Right? So they're not going to be able to grab stuff like the New World monkeys can. So that's a big split there. But if you look at arms and stuff, and we'll talk about this later on in the lab walkthrough, but they got those arm muscles. Those arms are set up for brachiation, which is to swing, right? So brachiation is how a lot of monkeys swing. And so if you've ever seen videos or pictures of monkeys and some of the primates relaxing, and they've got that arm over their head, which I'm doing, God, you can't see me. Okay. That's because their joints are made for that swinging motion, and that's the relaxing position for them, is kind of resting above their head. But you can see, you'll be able to identify all the bones that you need to. But it looks very similar to a human skeleton, obviously minus the tail. Humans have tails, but we can't do anything with them. Now, getting into the Chiropteras, okay? So we've got one of the mega Chiropteras, flying foxes, fruit bats, right? These things can get several pounds. If you look, they got that wing structure, right? It's just an arm like we have. The wings just have skin stretched through there, and their fingers are where it's going through, right? But they do not have echolocation. That's one of the big splits between the mega and the micro, or the big bats and the little bats, the yin something Coptera, the yang something Coptera. There's several more, but whatever. So you got big flying foxes, and they look like a fox that can fly. They're just super durable, cuddly, and they're massive, right? These things can have a wingspan of more than 4 or 5 feet. That's big, right? So the large flying fox, compare that to some of the micros. This is one of the smallest bats in the world. It's the Kitti's hognose bat. They do have echolocation, right? So super tiny, full grown, as you can see, not very big. There we go. And yeah, so big bats, little bats, some have echolocation, some don't. Most of the small ones do, most of the large ones don't. But again, that's a usually, as in pretty much every rule of life that I've given you this semester, there's a usually involved. Now we're going to move on to the rodents. Okay, rodents are what you're going to think of. You got things like mice, rats, beavers, and squirrels. And one of the key things for the rodents is, we'll look at this, we'll look at the beavers in a second, but they've got these ever-growing teeth. But what makes them interesting, so we'll look at the beaver. Okay, the beaver jaw here, right, you've got these sets of incisors, okay, always growing, meaning that that's why you see, like, if you got a hamster as a kid, they're always chewing on stuff, and gerbils always chewing, because they have to wear those teeth down, because they're evolved to always be chewing stuff. And so if there's like us, you wear your teeth down, you got once your adult teeth come in, you're done. You wear them out, you're done. Right? But they're self-sharpening, meaning that they've got a hard bit of enamel on the front, but so enamel on the front where you see it brown, no enamel on the back, so it wears out unevenly. So it's always going to leave that hard enamel as a sharpening bit. So they're called self-sharpening, because they wear down unevenly. So it's always leaving that sharp enamel to have a nice sharp edge to chew things through. But the reason they have to be chewing and wearing them down all the time is because if you don't give your rodent that you got as a pet something to constantly chew on, their teeth will keep growing to the point that they grow through their own skulls. Right? They'll just puncture their own skulls and kill themselves. Because you can't be like, oh, hey, teeth, stop growing, please. That's just not an option. So they got to keep wearing them down. But this is the North American beaver. The beavers belong to the genus of Castor. I'm pretty sure this is Castor canadiensis, but we'll just leave it as Castor species. American beaver. Got that big old flat tail for swimming, webbed feet. All right, webbed feet, flat tail. Beavers are one of nature's great environmental engineers. They can modify entire landscapes with their dams that they build, blocking rivers and all that fun stuff. Fun fact, beavers don't eat the wood. They chew the wood, poop it out, and then they'll eat their own poop the second time around because then it gets digested through all their gut bacteria. So yes, they chew the wood, they eat it, but then they actually digest the poop after it comes out. They eat it a second time. Bet you didn't know that. Now we move on to the lagomorphs. Okay, lagomorphs are going to be your pikas here. Okay, that's an American pika. Pika, I never know how to pronounce it. These things are ridiculously sensitive, like a couple degrees outside of their temperature range, and they drop dead. So global warming is very, very bad for them. Got your rabbits, all right, and then your hares. Even though they're referred to as jackrabbits, completely different species, completely different genus. All right, they are hares, and these are rabbits, little cottontails. You can tell by the size of the ears and the length of the legs and whatnot. But what's going to make them interesting, and you can tell that they're not rodents, when you look at their teeth. Okay, so this is the black-tailed jackrabbit, the Lepus californis, right? And if you look here, they have those really sharp incisors, and they've also got, stuff for grinding stuff up in the back, chewing on grass, but they've got a double set of incisors, okay? So they got the big main ones up in the front, and they have a second set behind them. So most other animals have their incisors. They'll be kind of in a row, so, like one next to each other. These are front and back. They got their two sets, which is very much a distinguishing characteristic of the lagomorphs. So moving past the lagomorphs, we go into the Cetariodactyls, right? So this is the combination which I've done for evolutionary purposes. So you got the artiodactyl, right, which means the even-fingered ones. So even-toed ungulates, meaning that they walk on 2 or 4 of their toes at a time. So you got things like cows, right, walking on 2 cloven hooves, deer, right, 2 toes, pigs, swine, antelopes, hippos. If you ever wonder that's what a hippo's foot looks like, camels, giraffes, right, even toes. Fun fact, Dr. Becca Lewison here on campus is the world's foremost expert on the common hippo. Academics rank each other on how well they know stuff. She is the #1 world authority on the common hippo. If you've any interest, join her lab. I did some time in researching with her lab. Got to look at cameras from looking at gold monkeys in China. That was awesome. Anyway, the cetaceans are put in there, and cetaceans are your whales, dolphins, and porpoises, because about 50 or 60 million years ago, they also fell into the even-toed ungulate category. They were walking on land. They walked on, even numbers of toes. So that's why they're evolutionarily clumped in with these guys. They just broke off like 50 or 60 million years ago, and now they don't have any outside legs, but they did have them. So looking now, we got the cetaceans specifically. All right, so you got like your baleen whales, you got porpoises, and you've got dolphins. Right? So they're all fall into the cetaceans category. So even though you got differentiating, you got Mysticeti whales and the Odontoceti whales, which I think I cover next. So you got toothed whales and baleen whales. And cover that in 1 second. Okay, yeah. So Odontoceti are going to be your toothed whales, right? So that's going to be things like dolphins, the porpoises, orcas, which are just the largest member of the Delphinidae. I don't like them. They're kind of, I can't say the word. Yeah, they're not very nice. got video of them playing hacky sack with a seal in front of his parents, and then he just kills it for no reason because they can. Um, yeah, I don't like orcas. Orcas got the name of, we call them killer whales, but they're better known by their old name of whale killers because their primary prey are Mysticeti whales, the baleen whales. Anyway, if you look, the teeth on the Adoniceti whales, lots of little pegs going after fish. Compare that to the Mysticeti whales, the baleen whales, and they have baleen plates, right? And these are just, if you look at them, they're basically, like keratin or like hair just really packed together, and they make them for filter feeding. There's only one baleen plate, so it's usually it's on the top, it's in the top jaw, going down, and they'll just gulp big things of water and push all the seawater out and swallow what's ever inside. A lot of times they go after things like krill, which is tiny little crustacean, like little shrimp, but there are other ones that go after bivalves. They dig in the dirt with their jaws, so they go after small fish, but massive filter feeders. Right? That's a baleen plate. Oh yeah, Parasitactyla. Okay, so these are going to be your the other ones were even-toed, and now we've got the odd-toed, right? And that's going to be things like your horse and your rhino and your tapirs. The name literally means the odd-fingered ones. So, you ever seen, you got horse hooves, right? That's essentially a middle finger that they're walking on that has become one big finger, and then the rest of their bones have, receded, and that's what you got left. The tapir foot up here, where's my little mouse? There it is. So we got a tapir foot, right? So you got walking on one, and then these guys walk on three, and rhinos, right? They walk on three, right? Odd-toed, even-toed. And a little more explanation on that one, right? So your odd-toes, okay? Like your horse here, right? It's basically walking on its middle finger. Same thing with the tapir foot, right? It's walking on three. Whereas the even-toeds, right? You got a deer, you got camel, and peccary? I don't know what that is. But even, right? So split between two versus weight being mainly on one. Now we're going to look at the Afrotheras, right? So we got your rock hyraxes, your sirenias, so you got your manatees and your dugongs, and your proboscidae or elephants, right? The rock hyraxes are really cool. They got little hooves on their feet, and when we look at their skulls, which we don't have, we have it in the lab. They're kind of evil looking, but they're really adorable, and we'd be looking at them if we were at the zoo because they're right there, but we can't do that. So, moving on. So for those, you're supposed to look at the elephant head, and it's especially with the tusks, and we call it a conveyor belt type of tooth system. So lower jaw, right? It's got these big grindy molars, but it also has incisors, which come out as, boom, it's tusks, right? Tusks are simply modified incisors, right? But it's grindy molars, okay? It comes in, they don't have it all at once. If you think of a human, you've got all our main sets of molars comes in, and then sometimes we get wisdom teeth that come in, between ages like 16 and 25, and some people have to have them removed to come in crooked, but it's kind of like a backup set. For the elephants, they're just anticipating that they're going to grind and break, and their teeth are just going to keep falling out. And so they get a couple of sets. So you can tell the age of the elephant by how many teeth they have left. Right? So between 0 and 2, they got teeth here. And then as those ones fall out, they keep getting replaced, and they keep getting replaced until they get their last large set in around 30 years old. But just because they get their last set of teeth in doesn't mean they stop getting ground down and broken. And eventually, what happens to kills a lot of elephants in the wild is their teeth fall out and they starve to death. Kind of sad, but nature can be horrible. But also means they live for that long out in the wild. It asks you to compare so we got just a kind of a general lizard skull to look at, right? The teeth, not much difference in all their teeth. Sometimes they're different sizes, but they've got that same general peg-like structure for grabbing onto, I think this is a small crocodile, for grabbing onto fish and just kind of throwing it back. Whereas again, I'm pretty sure it's a chimp. We have got incisors, we got canines, we've got premolars, we have got molars in the back for grinding up stuff. So they do a comparison. You got lizard, and you've got mammal. Sorry, lizard and mammal. Next, we're going to look at the different types of mammal molars, and this is just a small selection. There are way more than this. Okay, but you got the bunodont, you got the solenodont, and you got the lophodont. And so, like, we have the bunodont teeth, right? Us, chimps, and a couple other things. And it's just the shape of the way the tooth is, right? So you think of a human molar, that's going to be your bunodont tooth. Okay, so cups and the crests are going on about here. Compare that down here to a solenodont that's going to be like a horse tooth, and this happens to be a deer skull, or sorry, a deer jaw. So you can see the difference in the shapes, right? You got the bunodont up here, and you got the solenodont down here. And then the lophodont are going to be things like rodents and some of the elephants. So it's just the way that the shape of the tooth is and how well it grinds and stuff. So if it's going to be doing a lot of grinding, it goes for the lophodont style. Next, you need to look at the head ornaments. Okay, so we've got true horn. All right, true horns are going to be found on things like cows and rams, and sheep, and some other things like that. Right? Antelope, goats. So you've got a core of living bone. Right, so goes the skull, and the bone is there, and living bone all the way through. And there's a keratinous sheath that goes on the outside of it, and these are never shed. They can get broken off, but it's a traumatic experience because that's a piece of bone getting broken off. But if you ever think of like the old school drinking horns or playing a horn like trumpety ones, they would just remove after they kill it, they remove the keratinous sheath, and you got this drinking horn that you can make out of, right, or powder horn, whatever you want to use it for. So you remember, core of living bone, cover the keratinous sheath, is not shed. Right? It should not be coming off of this thing's skull without some traumatic event happening. Antlers, on the other hand, it's just a core of, it's a bone that's got skin covering it, but only skin covering it while it's growing, because these are shed every year. So in this, during the growing season, they're covered in velvet, right? That's while it's growing, and then they all die. So if you ever see something nasty, the antlers being shed, right? There's this bloody mess because all that skin is sloughing off, and you're left with a bunch of bone on there. Now think about that. That is solid bone that's getting grown and shed every year, and the pattern is the same. But this keeps getting bigger, more complicated, but that's actually kind of interesting. So think of how much energy and mineral nutrients it's going to take for like a moose or a large buck to grow and shed this amount of bone every single season. Right? They're shed every year. But antlers, skin covering during the growing period, but it's only bone when it's mature, and then they just fall off along these little planes where they're supposed to. Right? Every year it comes off. The next year just comes back bigger and badder, but with the same growth, same pattern. Pronghorns are this weird kind of combination of the first two. So it's a bony core covered with a sheath derived from the hair, which is bony core is permanent. The sheath is shed annually. So this is only found in the pronghorn antelope, American native, right? Found in the Midwest. One of the fastest things currently living in the Americas. So a little more hard to explain. Just know that pronghorns are not horns and they're not antlers. They're just kind of a combination of both. Rhinos, it's, we say rhino horn, but it's not horn like any of the other ones, right? It is mostly derived of keratin, right? It's the same stuff that your hair and fingernails are made out of. And that's what this stuff is down here, okay? So there's no bone involved. It's basically just an elaborate fingernail, which is why it has no medicinal value whatsoever. And yet people are still stupid and they're still poaching these things and they're still cutting off their horns and killing rhino, which is why the populations are dying out and they're going extinct. Because humans are stupid. Rhinos are very fast for how big they are. They're incredibly agile. And yeah, I got to meet one. It was like 20 days old and tried to flip us over. But whatever. Different story. Now, the last but not least, we got the ossicones. Ossicones, short, unbranched, permanent processes in terms of like a projection of the bone, right? covered with hair and skin. It's found on the okapis and on the giraffes. Okay, so they're always there, and they are used for weapons. Study determined recently that the reason giraffes are so elongated is not to do with finding food on the top of the branches. That is a side effect. It was sexual selection to fight each other over mating using these ossicones. Right? I normally would have been beating the term ossicone into your head because it used to be a question on the exam and everybody got it wrong because they confused it with ossicles, which were from the echinoderms. Example of misspelling, that is spelling the wrong thing. Ossicones, giraffe, thing on top of their heads, and the okapis have the same thing. Mammal locomotion, right? Generally breaking this down. Again, we talked about the brachiation, right? So that's what swinging from tree branch to tree branch, what our ancestors did, what modern primates and monkeys are doing. Fossorial, right? That is the term for digging through the dirt, right? Got your moles and your shrews doing that. But then you get your saltatorial, so the jumping, right? Very efficient, all that power going just one movement. To the best of my knowledge, kangaroos cannot move their hind legs independently. It's always just a jump. And they've also got that tail, which acts like a big third leg in the back. They can actually lean back on the tail and kick the crap out of you, which is why don't mess with kangaroos, at least the big ones. Okay, this is the end. Just want to thank you guys for a great semester. It was really fun getting to know everybody, and I would like to thank everybody again for your patience dealing with this absolutely insane semester that we've had. Good luck with the rest of your classes. Hopefully, this will be one of the least stressful ones you have to deal with. The Lab 15 write-up will be due on Friday instead of Thursday, just by the end of your normal lab section. So Section 5, 11 a.m., and Section 7 at 8 p.m. on Friday. Just get it to me as soon as you can, and everything will be good. So enjoy and stay safe, everybody. Take care. And don't hesitate. You got my email. Don't hesitate to contact me for anything you need. Stay safe and wash your hands. Bye.